Hey everybody, welcome back. Today's section is on logarithms and logarithmic functions. A logarithm is basically just an inverse of the exponential functions, and that's what we focused on in the last unit, where we looked at the equations of exponential functions as well as their graphs. So this unit's going to be focused on all of the inverse of those functions. I've written here in green an example of an exponential form of a function, and then we wrote it in orange in the logarithmic form, and that is the inverse. So notice in the green one, it's y equals 2 to the power of x. The inverse of that, or the logarithmic form of that, would be x equals 2 to the y. So notice the only thing that we did here was switch the x's and y's. And if you remember back from our inverse unit, that's all you have to do, switch the x and y's. That's this first step. So instead of leaving it as x equals 2y, they developed this fancy form where we write it log base b of x equals y. So these two things right here and here are the same, just written two different ways. One is in exponential form, one is in log form. And this, I want to point out, b stands for the base. Okay. The y is your exponent. It's very important. Okay. And then x is going to be whatever your answer is equal to.
So the easiest way to remember what each letter represents is to remember this little saying, a log is an exponent. So that just means that the log equation is always equal to whatever your exponent is. That's also going to help you if you have to switch back and forth from logarithmic form to exponential form, because you know that this number at the end after the equal sign will always be your exponent. All right, so let's use this and solve some log functions. So it says here in example 1, log base 2 of 8 equals x. Now I want to make sure you understand one thing. This little 2 here is a subscript, so it's tiny and it's lower than the log and the 8. This is not 2 to the 8th, okay, so the 8 is not an exponent, so keep that in mind. The log, the 8, and the x are all in the same row. The 2 is just below everything else. Okay, so log base 2 of 8 equals x. So remember our saying, the log is an exponent. So the log is an exponent. That means the x is our exponent. Okay, and we say it log base 2, so that's the base. And now I could change this to exponential form and it will make it much easier to solve. So I'm going to write my base 2. My exponent we said was x, and we're going to set it equal to our last number, which was 8. So what this means is 2 to some power will get us 8. So then you could do some mental math. 2 to the third equals 8, so that means that x is equal to 3. And then you're done. Okay, so let's try another one. Log base 5 of x equals 3. So remember, the log is the exponent. So the log is the exponent. That means that's my exponent. Okay, here's my base. Okay, so I'm going to write 5 to the third power equals x. And then you could just go ahead and simplify this. So you get 25 times 5, that's 125. And then you'd be done. All right, so as long as you can remember where the exponent is and where the base is, you should be good to go. You just switch it to exponential form. Here's an example where I give you a form and you have to switch it back and forth. So in example 3, it says 4 to the third equals 64, and I want you to change it to log form. And to do this, you have to know which parts go where. So remember, we start with our base. The base is 4, so we're going to have log with a base of 4, so a little 4 there. Remember, the exponent is what it's equal to, so we're going to make it equal to 3, and that means the 64 goes here with the log. So exponent is always after the equal sign. And you're done. So that goes from exponential form to log form. And if we want to do the same but reverse, okay, this one just says evaluate. Notice there's no x in this, but we're assuming we're solving for x. Okay, so don't be confused if you don't see an x. If it's asking you to evaluate, they're wanting you to solve. So in log form, we change it to exponential form. So I'm going to say change to exponential. And remember, we can find our base. So our base is 1/2. That's what's here. We don't know what the exponent is. We don't know what it's equal to. Okay, but we know that our final answer has to be 256. So this one's a little trickier because we've got a base that's a fraction. So there's a couple things you have to pay attention to. you started with a fraction, but you end up wanting a whole number. So the only way to switch from a fraction to a whole number is to have a negative exponent. So that's going to be important. Your answer is going to have a negative in it. And then you have to think about what power 2 has to be taken to get 256. And you might have to do some experimenting a little bit with your calculator, but it turns out that 2 to the 8th equals 256. So I have to change 1/2 to a 2 by making it negative, so I'm going to have negative 8. So you could double check 1/2 to the negative 8th. That's going to flip my fraction and become positive 8, and then that's going to get me 256. And that would work. So our final answer here is x equals negative 8.